Hello, everybody. Looks like there's a lot of people in the chat already. Oh, I should adjust my bow tie. Yes, well, hello, Dylan. Hello, Dylan. Hello, Veronica. Hello, Alyssa. Hello. Yes. Well, as you know, my name is Andy. Bow ties are cool. Science Center is still closed for the health and safety of our guests and our staff and our partners, but we're still going. So every morning at 10:30, we're going to have all these fun science activities for you. So make sure you come back every day at 10:30. Today, I have something really cool to share with you. This is one of my favorite topics in science, and that's magnetism. So I have a magnet right here, normal, everyday magnet. And of course, magnets, they can pick things up. Move these so you can actually see them. Magnets, they can pick up metal, but only certain types of metal. So this is iron or steel. Magnets can't stick to things like plastics. Here's a tube. It's not sticking. Not going to work. Magnets can't stick to things like cork or whatever. It's not sticking. It doesn't work. So some metals, like this penny is not made out of a certain type of metal. Some metals don't work. Only certain metals work. So for instance, iron and steel are the only types of metals that can work with a magnet. And we're going to explore that today. So this is a normal magnet. I also have these. These are also magnets. They're stuck together. Magnets have a north pole and a south pole. So these show that really well. This magnet right here, if I try to put these together, it's not going to stick. In fact, it's going to make it just push away. And at some point, the magnet, it wants to stick to the opposite pole. So if this is north and this is north, they won't stick together, but it'll actually spin around so that the North Pole and the South Pole will stick together. So for instance, this base has a magnet in it, and so I'm able to repel that red magnet because the base is magnetized, and I can stick the red magnet to it because the base is magnetized. So I can stack these up, and as long, whoops, not that way, as long as they're all the same pole, as long as they're all the same pole, so let's say they're all north, then they'll stack up and repel away from each other, which is really cool. And here's another really cool thing. I can squish them together, and I'm not touching the yellow one or the green one. I'm only touching the blue one, and they will squish together, and I can make them launch like that because it builds up that energy and gets them going. So there's some energy, there's some force behind that magnetic field. This is one type of magnet. These are pretty weak magnets. I have some stronger magnets here. This is a neodymium magnet. Well, it's several neodymium magnets stuck together. And neodymium magnets are really, really strong. So this is a normal magnet. And if I bring this, whoop, that was really, really far away, and I can push this from much farther away, and it flips it really easily. In fact, the neodymium magnet is so strong, it can steal. So this neodymium magnet is so strong, it's stealing paper clips from this weaker magnet. If I get it close enough, it'll steal it. So neodymium magnets, neodymium is a special type of metal. It's a rare earth metal, and it's one of the materials that can make magnets. This one is likely a ceramic magnet, which means it has a ferromagnetic material, something that's either iron or even nickel or cobalt, and it was manufactured in a way that it's a permanent magnet. Oh, are magnets man-made or from the earth? A little of both. This is a man-made magnet. So the neodymium magnet is man-made. So this is a synthetic magnet made with rare earth metal. But you can find things like lodestone and magnetite that are naturally magnetic. It depends on how the materials cool, how the minerals form, and every magnet has things called domains. There are these little microscopic regions inside the magnet where the magnetic fields are going in certain directions. I have some other things here that I can show you. Here's something I'm going to show you. I have a coil of wire here. So I mentioned that things like copper, so I have this penny. The penny will not attract to a magnet. Nickels don't attract to magnet. And this doesn't attract to a magnet because it's made of plastic. But even though this metal doesn't attract, it still reacts to the magnet. If I drop this through it, it falls a little slowly. So I put it in top. It takes a little bit of time to go through. If I drop something normal, like a paper clip, it goes straight through. But if I drop this neodymium magnet, it slows down. And I can show you that in a bit of a bigger way. I have a copper pipe here. So I have a cardboard tube and a copper pipe. Cardboard is not magnetic. I'm going to get up and I'm going to hopefully not. My cat is hiding. Okay. So first things first, I'm going to drop the neodymium magnet onto the table through this tube, which may be the dumbest idea I've ever had, but it's worth a shot. I'll put it on a notebook so it doesn't cause too many problems. One of the dangers using magnets is it will stick to everything if it's magnetic material. So neodymium magnet through a cardboard tube. I'm not doing anything funny. I guess that counts as like 5 points because I managed to get this magnet in this cup of water. Okay, so you saw it went straight down, hit the notebook, bounced off, threw that other magnet into the water, which I'm going to have to get that magnet out because that water's for a later experiment. But if I drop it through a copper pipe, nothing funny about this copper pipe, you can see right through it. And if I drop it through the copper pipe, it doesn't bounce off the notebook, fly into the bowl, Canton does it to get our mass hysteria. It slowly goes through, and it's really awesome why it does that. I'll show you in a small scale. First things first, I'm going to get that magnet out of there. Oh, no, okay. Perfect. You can stay over there. way over there. Okay, so here's what's happening. In the copper wire and the copper tube, right there, even though this isn't magnetic, it's still metal. And metal conducts electricity. And whenever you have a magnetic field, you have a little bit of electric current. And you may remember last week when I made this thing. Where did I put it? Where did I put the... Oh, it's right there. I made this motor. If you haven't seen that, definitely check it out in the archives. Oh, come now. Why are you leaning over? Oh. It did that last week, too. Yeah. All right, let's try this again. Okay, so this is happening because there's a little bit of a current going through that wire and a little magnetic field going through that current, and the current and the magnetic field interact. Okay, you can... I'll just let you do your thing. I don't want to actually wait. Perfect. So what's happening here is neodymium magnet induces a current into the wire or the tube or what have you, and that has a magnetic field which interacts with the magnet, which is... Now, if you happen to have copper tubing and neodymium magnet, you could try this breaking experiment at home. But this is one thing that you can try at home. Even if you have a weaker magnet like this, if you take a paper clip, I'll use this little paper clip, and I'll use this strong one. If you rub a paper clip in the same direction, like 50 times like this, then you can give it a pretty decent magnetic field. So I've lost count. I'll just assume this is right. And that's where this bowl comes in. So I'm going to move this out of the way. And this bowl has water in it. And I'll keep rubbing this paper clip. I'm going to make a compass. So I know north is that way. And if this compass works, then it will point north, because the Earth has a magnetic field. And compasses work by pointing to magnetic north. So I'm going to place this in here. It's sort of working. I'm going to grab the camera so you can get a closer look. So you can see the paper clip. There it is. The paper clip has sort of moved itself. And if I twist it, then it'll stop. Whoop, there it goes. There it is. It stops, and then it starts to turn back the other north and pointing north. I have another compass here, and I made this by taking a neodymium magnet and gluing it to a piece of card. So I'm going to put that in here, and it should do the same. So there we go. Right away, that neodymium magnet compass twists and points north. So there you go. I'm going to put the camera back. Okay. And that brings me to your challenge. See if you can, at home, if you have a magnet, if you have a magnet at home, you can try to make your own compass and see if you can improve on my design. See if you can improve on my paperclip and card design. There's different ways to suspend it, for instance. so that gravity's not affecting it that much. And there's different things that you can do with magnets. Magnets are all over the place. One thing that people don't normally think about is magnetic fields are used in computer screens, which is why you need to be careful with magnets so that it doesn't get too close to a computer. It can mess up the screen because there's little tiny magnetic fields in there that make electronics work. And we know that magnets interact with electric current. So we need to be careful with those. Look at that. I'm making the compass swim. Okay. That's how strong this neodymium magnet is. It's pushing and pulling on that, even from that far away. All right. Well, I've come to the end of my time. Thank you very much for coming to this installment of Curiosity Corner Live. Come back at 3 o'clock because I'm going to show you how I made this magnet. One little final thing to show you. That is my cat. There we go. And then if I take this wire off, it's not a magnet anymore. All right. Magnetic dry erase board by your computer shouldn't be bad. The dry erase board probably has a little thin sheet of steel or something like that. And so that's how a magnet can stick to it. So the magnetic field shouldn't be that strong, so it won't hurt your computer too much. Anyway, thank you very much for joining me, and I'll see you later today, and where I'll explain how I made this. I have one cat. He's just very loud. All right. Bye, everybody. Thanks for joining me.